we are looking at question number 9. The question says, a teacher demonstrated the relationship between the pressure in a gas and volume of the gas. So this statement means the teacher is trying to teach students how pressure in a gas is related to its volume. So you need to remind yourself, based on your learning, that product of pressure times volume is always equal to a constant, provided mass and temperature, they remain constant. So if you keep the mass and the temperature of the system constant, then the product of pressure and volume will always remain constant. The question then says, figure 12 shows the equipment used. They've got a pressure gauge connected to a gas syringe containing gas. Now, in this case, the volume in the gas syringe can be changed because the plunger is connected to weights. Based on this diagram and our understanding of pressure and volume of a gas at constant temperature and mass, we can work out the relationship. So we'll say here, if my weight goes up, then the volume in the syringe will go up. And if the volume goes up, then the pressure should decrease. The question then further says, this is the method used. Number 1, record the initial volume of gas in the syringe and the pressure reading before any weights are attached. This means when the value of weight is equal to 0 newtons. Then it says attach a 2 Newton weight to the syringe. Number 3, record the volume of the gas and the reading on the pressure gauge. Repeat step 2 and 3 until a weight of 12 Newton is attached to the syringe. The first part of the question says, what is the range of force used? So we started with 0 Newton and they went up to 12. So the range will be 0 Newton to 12 Newton. Now in this question, majority of people wrote answer as 2 Newton to 12 Newton. This is because they did not take into consideration the first statement. The question then says, give one control variable in the investigation. Control variables are those which are kept constant throughout the investigation. So in this case, what they are doing is they are trying to work out how pressure of a gas depends on its volume. So they can't change any other variable. For example, we learnt about 2 variables here, mass and temperature. So you can say mass, that's option 1, or you can say temperature of gas. Next part of the question says, when the volume of gas in the syringe was 45 centimeter cube, the pressure gauge showed a value of 60 kPa. So this is my value of V and this is the value of P. It then says, calculate the pressure in the gas when the volume of the gas syringe was 40 centimeter cube. This is again my volume, and the question is talking about finding pressure. So in this question, I can see 2 volumes are provided. So I'll say this is volume 1, which is volume at start. This is pressure 1, which is pressure at start. This is P2, which is not known. And this is my volume V2. We looked at the start, there was equation. The product of pressure and volume will always remain constant. I can use this concept, and based on this concept, there is an equation which links these 4 variables, and that is P1 times V1 equals P2 times V2. This equation is telling me that the product of pressure and volume at state 1 will be equal to the product of pressure and volume at state 2, provided mass and temperature are kept constant. So all we have to do is plug in values into this equation and solve. But before that, I would like to remind you about an important thing here, that units must be same on both sides. Now, what does this mean? This means whatever the unit of pressure is on the left side, it should be the same on the right side. Whatever the unit is for the volume on the left side, it should be same on the right side. So we can see here we've been given 2 volumes and they both have same unit, which is centimeter cube. So we don't have to worry about that. We've been given pressure 1 as 60 kPa. We've been asked to find P2. And if you look at it, P2 also has same units as P1. So we don't have to carry out any unit conversion. We simply have to plug in the values and solve. In this case, P1 has a value of 60. B1 has a value of 45. we do not know the value of P2, the value of V2, which is 40. Now, to solve this equation, what will I do? I'll divide both sides by 40. This 40 will cancel out and I'll be left with only P2 on the right side. If you plug these values in your calculator, you'll end up with a value of 67.5 kPa, and this is my answer. Next part says, when the volume of gas in syringe increased, the pressure on the inside walls of the syringe decreased. They're saying if you increase volume, pressure goes down. They're asking for what is the reason for this. Before I start working on this question, I would like to remind you about an equation for the pressure, which is pressure equals force per unit area. In this case, the value of A is fixed. It is constant. The value of force will depend on the amount of collisions between particles and walls. In 1 second. Number 2 will also depend on the speed of particles. Now in this case, this is constant because temperature has been kept constant. In this case, I will only focus on option 1. So I will say number 1, as volume increases, less collisions between particles and walls take place in 1 second. Number 2, force will go down. And number 3, I'll say pressure is equal to force over area.